Hello, this is Mr. Hanksman, and these are your section 11.2 notes on combustion reactions. All right, so with combustion reactions, well, combustion is burning things. So you might know that you need oxygen to burn. So that's what's going to give this reaction away. If we see O2 as a reactant, that should tell you that it's going to be a combustion reaction. So we want to see O2 on the left side tells you combustion. Now there's going to be two general forms of this. So this first one right here, this is combustion of an element. So A, we're going to use that as a general term for any element. And when you combust that with oxygen, we're going to make some sort of oxide. Now the identity of the oxide that's your product is determined by whatever that element is and what ratio you have between that element and oxygen. Now you might look at this and say, well, that's also a combination reaction because you have just a single product, and that's true. With this type of reaction, you could classify it as either combustion or a combination. Both would be correct. All right, now the next one right here, the CXHY. So when you have any combination of carbon and hydrogen, when you combust that, we always get the same products. You always get CO2, carbon dioxide, and H2O, water. Now this reactant right here, the CXHY, that's called a hydrocarbon. Okay, hydrocarbon. You can have any ratio of carbon and hydrogen, and you always get the same product. So it makes it kind of easy. As long as you recognize this, we don't have to think about charges or anything like that. The products are always going to be the same, carbon dioxide and water. And then you just have to balance that out. So let's look at a couple of examples here. All right, so you got C4H12 plus O2. Well, first of all, we can tell it's combustion because of O2 on the reactant side. Then the next thing, this is a hydrocarbon, the C4H12. So when you combust a hydrocarbon, we always get carbon dioxide and water. So those are our two products. The last thing you do now is you balance this. And there's a special order in which you balance these combustion reactions. And you'll want to write this down. You balance carbon first, hydrogen second, oxygen third, and then once in a while you might have to go back and double everything to make the oxygens work out. We'll see that in some of the examples that we do. Okay? So with this one, we'd want to look at carbon first. So there's 4 carbons here. So we'd want to put a coefficient 4 in front of the CO2. Then we look at the number of hydrogens. There's 12 here. There's 2 here, so we'd want to put a coefficient 6 in front of the water. Then we would add together the 2 oxygens on the product side. So when we put a 4 in front of CO2, now you got 4 times 2, so that's 8 oxygens. And then when you put a 6 here, now you have 6 oxygens from here. So 8 and 6 gives you 14 oxygens. Well, we can put a 7 in front of the O2, and now that's all balanced out. So there's your balanced equation. So just like any other reaction, we want to figure out the products first and then balance it last. Next example right here. You can tell it's combustion because of the O2 being a reactant. And then this is, even though this OH is right here, this is still considered a hydrocarbon. So we're going to get the same products. It's going to be CO2 and H2O. With this OH at the end, that's a type of alcohol. So alcohols have that OH group. This one is ethanol. So when we combust ethanol, we still get CO2 and H2O. And then to balance this same process, we'd want to balance carbon first. So we'd want to put a 2 right here. And then we want to balance hydrogens next. So there's 5 plus that 1, so you got 6. So you'd put a 3 right here. So that gives you 7 oxygens on the right side. There's 1 right here, so we need a 3 in front of that O2. So that's the balanced final reaction. Okay, now with this one, you should pause the video and try these out. You want to figure out the products for each one of these 3 and then balance them out. I'll go through the answers in just a second. Okay, so I'm going to go through the answers now. So I switched over to a Jamboard so I could write on the screen. But this first one, well, looking at all three of them, you can tell they're combustion because of the O2 being the reactant. But this first one is going to be combustion of an element. So we're just going to make one compound as our product, and that's going to be potassium oxide. So when we write out our product, we're going to make an ionic compound, so we have to consider the charges on the potassium ion and the oxide ion. So potassium is a +1 ion, oxide's -2, so that means we're going to need 2 potassiums for every oxide ion to make the product. So we write out the product based on the charges of these ions. And now we balance this out. So there's 2 oxygens here, there's 1 here, so you need a coefficient 2. And that gives you now 4 potassiums, so you'd have to have a coefficient 4 in front of the K on the left side. So that one's all done. All right, now the next one, this is a hydrocarbon. So our product is going to be CO2 and H2O. All right, and again, when we get this type of combustion, we want to balance carbon, then hydrogen, then oxygen, and then maybe double if we have to. All right, so on this first one, we have 2 carbons. There's just 1 carbon right here, so you have to have a coefficient 2. And then we have 4 hydrogens. There's 2 hydrogens here, so we'd have to multiply this by 2. All right, now we add up the oxygens on the product side, so there's 2 times 2, so there's 4 oxygens right here, plus another 2 oxygens from the water. That gives us a total of 6. So we can put a coefficient 3 in front of the O2 and it works out just fine. So that's that one. All right, now with this one, the products are going to be the same. CO2 plus H2O. And we go through the balancing process again. So we start off with 3 carbons compared to the 1 carbon. So we're going to put a coefficient 3. Then there's 6 hydrogens. Here there's 2 hydrogens, so another coefficient 3. And now we add up the oxygens. So there's 3 times 2, so there's 6 oxygens here, plus another 3, so that gives us 9 oxygens. Okay, so the problem with this one is we can't have an odd number of oxygens on the reactant side because of that 2. We can only have even numbers. So we can't put a coefficient 4.5 to give us 9, all right? So in that case, when we get an odd number of oxygens, then you go back and double everything. So we'd have to put a 2 right here. We'd have to change these 3's into 6's. So let me just get rid of those. Turn those into 6's. And now instead of 9 oxygens, now we have 18, and we can make that work over here with a coefficient 9 in front of that O2. And that works out and it's all balanced. Okay, and that's all for the notes for combustion. Have a great day.